Alrighty, so back in week 8, I did an example with the bearing using the law of cosine. And so I am, for vectors, I'm doing the same example. Let's just show there's week 8, and there's week 9. I haven't got the video, but there it is. There you go. See? Okay, you believe me now. Alrighty. So we're going to do vectors. You still have to change the bearing angle into what you're going to type in the calculator. And I just highly recommend that you change it to an angle in standard position. I kind of mentioned this maybe in a video. You don't want to suddenly have sine using the adjacent side and then just mess everything up. So I would much rather change the angle than change SOHCAHTOA. You get my idea. Okay, so let's just walk through this. So remember, this type of bearing is from the vertical. So southwest, you see right here down in quadrant 3, 40 degrees from the vertical, so 270 minus. And then our vector, I just take that magnitude, the number of miles, multiply by cosine for the x coordinate, etc. And then ditto for the 28, northwest is quadrant 2, so that's a little bit past 90, so add it to 90. There's the vector for it. And we want the resultant vector. You can see my correction tape marks. I was going to do it differently, but decided to do it this way. So we need the resultant, and you just add those two vectors together, which you see right there. I've got the same thing written twice, and type it in the calculator. Boom. I kept all these decimals because I wasn't sure if rounding it was going to cause a problem down the road. And then the magnitude is just the Pythagorean theorem right there. And since I'm on Blackboard, I will just go back to that bearing example in the law of cosines to show you. That's not the bearing example. I didn't even click on where zombie shark. There we go. What's going on? My upside down file here. So 20.7364 using the law of cosines right there. 20.7364 using vectors. So you had to change the angle in both of them. It might be the law of cosine, a little bit more work trying to get the angle in the triangle than to convert your bearing to an angle in standard position. But everybody does it differently, and whatever works for you, whatever you see when you start trying to answer the question, you just got to go with it. Now all the questions are not interchangeable. You could do it law of cosine, law of sine, or vectors. Some of them are not. So just be aware of that. Okay, so the other part of that question was the angle you go back to. So there's my law of cosine, and we had kind of a lengthy discussion about figuring out that angle. We had to use law of cosine to find part of it, and then the parallel line thing, and then we got it there. So let's look at the vectors, and that's why we need the resultant as is. So one of the things we've got to pay attention to is the direction. So the direction of the resultant is ultimately the direction the shark or ship was going. Now we want to go backwards. So we're going to go in the complete opposite direction. So this vector, negative x, positive y, is quadrant 2. So we're going to go back and we're going to sail towards quadrant 4, which will be southeast. And we move on. So I recommended that when you find these angles, you just do alpha, and that you make the numbers positive. So absolute value in there, tangent inverse, b over a, we get 19.87, etc. That's from the horizontal. That's what the reference is. And then you just subtract it from 90, and then there's 70, and that's what you put in between the letters. So to get the letters again, the resultant vector is in quadrant 2, northwest. We need to go in the opposite direction, which is southeast. When you use the calculator for tangent, you find the reference angle, and no matter what quadrant, you would subtract it from 90 to get the bearing angle, and then you use the letters according to the correct quadrant where you're going to be traveling. And that is the zombie shark ship example with vectors. And let's find where's the stop button. There it is right there.